In today's lesson, we are going to talk about the binomial theorem. You will be able to find the odd term of a binomial expansion, use the binomial theorem to expand pairs of binomials, and determine the number of subsets of a finite set. So let's look at first a binomial expansion. If I have a binomial a plus b and I raise it to the 0 power, since any number to the 0 power is 1, the answer is 1. If I raise a plus b to the first power, I get a plus b. If I raise a plus b to the second power, from your previous studies, you know that it's a squared plus 2ab plus b squared. If I raise it to the third power, I am going to get a cubed plus 3a squared b plus 3ab squared plus b cubed. And if I'm raising to the fourth power, I get a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth power. What I'd like you to focus on is your coefficients of each one of the terms. So if I'm looking at the coefficients, in the first expansion, I will just have a 1 in my answer. Then if I'm looking at the coefficients of a plus b, I will get 1 and 1. Then I look at the coefficients of a plus b squared, and it will be 1, 2, and 1. If I look at a plus b cubed, I have 1, 3, 3, and 1. And for the last one, which is a plus b to the fourth power, I will have 1, 4, 6, 4, 1. These are the values of the coefficients of each one of the terms. There are several patterns we can see in this triangle, what I just created. And this triangle is called the Pascal's triangle. There are several other pieces of information come out that are important of the binomial expansion. For example, if I'm looking at the different terms and I'm looking at the expansion a plus b to the first power, I will get a to the first and b to the first. In the next one, in the next row, I have a to the second and 2 times a times b, so a to the first is in here, and b is to the first power, and in the last term I have b to the second power. What happens in the first term that I don't have a b, and if you notice that b to the 0 power would give me 1, so this first term is really a squared b to the 0 power. Then I have 2 times a to the first b to the first, and then I have a to the 0 power times b to the second power. So what I would like you to realize is that the first term a starts out with the highest exponent 2, which was the exponent of the binomial here, and it decreases to 1 and then to 0. Whereas the second term in the first term is going to have b to the 0 power, then b to the first, and then b to the second power. If you want, you can go through the same steps on the next row and discover the same kind of pattern. On this slide, I gave you several representations of the Pascal's triangle. And as you can see, if you continue with the Pascal's triangle, you can go to all types of different exponents of a plus b or a binomial. And what I'd like you to notice that on the right hand side, I gave it to you in a form of different combinations. So if you are looking at the top one, which is the combination of 0, choose 0, if you expand it, you're going to get an answer of 1. If you look at the second row, you have 1 and 1, which is combination 1 choose 0 and combination 1 choose 1. And the next row is combination 2 choose 0, 2 choose 1, and 2 choose 2. And that's the expansion of the a plus b to the second power, and so on. If we look at the binomial expansion of a plus b to the fifth power, this is the expanded form. And this is the same expanded form written with combination coefficients. So for any binomial a plus b and any whole number n, I could have a plus b to the n power, and this is the expanded form. What I'd like you to notice is that the combinations are your coefficients, and we start out with the highest exponent on the first term, which is a to the n. Then in the next term, it's a to the n minus 1, and in the following term, a to the n minus 2, and it goes all the way to the last term where you don't see a, is where a is to the 0 power. And b starts out with the 0 power, that's why we don't see it here. And then we have b to the first, to the second, all the way to b to the n power. So a plus b to the n power is the sum of all of these terms. So these are each individual terms, and this is the sum of all the terms, starting with the 0 term to the n term. And n over r, or the combination n choose r, is called the binomial coefficient. In the first example, x plus y is to the fourth power, so we need to expand the expression. So I'm going to start with the combination of 4, 0 times x to the fourth power and y to the 0 power. Then my next term is going to be c4, 1, x to the third power, y to the first power. The next term is going to be combination 4, 2, x to the second, y to the second. Then we are going to have combination 4, 3, x times y to the third power. And for our last term, we are going to end up having c4, 4, x to the 0, 0 power, and y to the fourth power. So now I'm going to have to expand all my combinations. So I'm going to start with c4, 0, which is 4 factorial divided by 4 minus 0 factorial times 0 factorial. And that is 4 factorial over 4 factorial, so the value is 1. So my first term is going to be 1 times x to the fourth power. Then for the second term, I'm going to evaluate c4, 1. So that's 4 factorial divided by 4 minus 1 factorial times 1 factorial, which will give me 4 factorial over 3 factorial. So this one is going to give me an answer of 4. So this will be 4 times x to the third power, y to the first power. The next term is going to be c combination 4 choose 2. So it's 4 factorial over 4 minus 2 factorial times 2 factorial. 4 factorial over 2 factorial times 2 factorial. 4 times 3 times 2 times 1 over 1 times 2 times 1 times 2. So if I simplify, the 2 times 1 goes away, and I can simplify by 2. So my final answer here is going to be 6. So this will be plus 6 times x to the second, y to the second. Then the following term is going to be combination of 4 choose 3, which is 4 factorial over 4 minus 3 factorial times 3 factorial, which will give me the same answer as 4, choose 1. So the final answer here is going to be 4. So my next term is going to be 4 times x times y to the third power. And the last term, which is combination of 4, choose 4, is going to have a value, the same value as the first one. So the value of this is 1. So my last term is going to be plus y to the fourth power. So here is my expanded form if I'm using combination. In any of your homework assignments, if you prefer to build your Pascal's triangle, you can also do that.